Hello friends, welcome to Electrical Design Engineering YouTube channel. This is lecture number 26 of our free course Etap. In this lecture, we will take an example and calculate PSM, TSM and plug setting of a relay. Before starting the lecture, please subscribe the channel and like and share the video on your social media profile. Design a protection scheme for a 33 kV feeder supplying a load of 5 MVA, and we need to coordinate between the primary feeder relay and the backup transformer relay. The fault current for the system is 5000 amperes and having a CT ratio of 200 by 5 ampere. That means we have to make a protection scheme for a 5 MVA load with a fault current of 5 kiloamperes and a CT ratio of 200 by 5. We have to make a coordination between primary relay, feeder relay and the transformer relay. Step 1. Calculate the rated current. First step is we have to calculate the rated current of the load. Transformer rating is 5 MVA, voltage is 33 by 33 kilovolt, rated current will be 5 MVA divided by root 3 into 33, that is 87.58 amperes. Second step is to calculate the current in the secondary of the city. We have a city of 200 by 5. We have to calculate what will be the current in the secondary of the city. City secondary current is called 87.58 divided by 40, because 200 divided by 5 is 40. We have to divide the city ratio, that is 40. It becomes 2.19 amperes. That means in the city secondary we have a current of 2.19 amperes. Pickup current is equal to rated current. The plug setting here, the rated current is the city secondary current. So pickup current is equal to 2.19 into 1.25, it becomes 2.74 amperes. Calculating the plug setting multiplier. Now we have to calculate the plug setting multiplier. PSM is equal to fault current divided by pickup current. Fault current is 5000. Our pickup current will become, that is city's current in the secondary into city ratio, that is 40. It becomes 45.66 amperes. 66. This is PSM ratio. This is not ampere. It is a ratio. Now calculate the time multiplier setting. Suppose we have using a relay with standard inverse characteristics with TMS equal to 0.2 seconds. That means for a standard inverse characteristics, our TMS is equal to 0.2 seconds. Calculate the operating time of a, now we will calculate the operating time of a relay. T is equal to TMS into alpha and beta divided by 1 by P alpha minus 1, that is equal to TMS into beta divided by PSM alpha square. Alpha, that is power alpha minus 1, because I by IP is equal to PSM. So we have written beta divided by PSM alpha minus 1. T is equal to TMS is 0.2 seconds and into beta divided PSM is 45.66, which we have early calculated, beta minus 1, alpha minus. Now this is the standard characteristics, the values of alpha and beta. So we have to using the standard inverse relay, that is the normal inverse relay, that is alpha is 0.02 and beta is 0.14. Putting these values in this equation, we will get the value of Tm. Tm is equal to 0.2 into beta is 0.14 and alpha is 0.02, alpha is 0.02 minus 1. It becomes 0.34 seconds. So operating time of the primary relay is 0.354 seconds. Now second is the coordination time interval, that is we have to make a coordination between backup relay and transfer feeder relay and the backup relay, that is the transformer relay. So considering the CTI of 0.3 seconds between backup relay and the primary relay, operating time of the primary relay is 0.354 seconds and operating time of backup relay is 0.354 plus 0.3, that is 0.65 seconds. Thank you.